Hi, welcome to our next level 3 trigonometry video. We continue talking complex trigonometric equations. So here's our first example. Tan squared of 2x minus 1 equal to 0. And we're going to find all solutions between x is 0 degrees and 180 degrees. Right, let's pop the negative 1 onto the other side to get tan squared of 2x equal to 1. Now this tan squared here means tan of 2x times tan of 2x is equal to 1. Now, when we have something times itself equal to 1, we either have 1 times 1 is 1, or we have negative 1 times negative 1 is 1. So we can say tan of 2x is either going to be 1, or tan of 2x is equal to negative 1. Now, we've broken that up into smaller equations, easier to deal with. So let's go into our graphics calculator and solve each one of these. So let's go tan of 2x as our graph, and put that for y2 equal to 1 to start with. So tan of 2x is equal to 1. And let's draw the graph. Now I've set my calculator up into degrees. And in my view window on the x-axis I've gone from 0 to 180. And I've just chosen some y values, negative 4 to positive 4. Right, let's go G-solve and find the intersection. Our first solution happens to be 22.5 degrees. And another solution at 112.5 degrees. So there are two solutions for when tan of 2x is equal to 1. Now when I back up and change this to negative 1, tan of 2x is equal to negative 1, you can see that there are two more solutions. The first one happens to be at 67.5 degrees, and our second solution is at 157.5 degrees. So there's two solutions for tan of 2x equal to negative 1. So we have four solutions altogether. We have x is equal to 22.5 degrees and 112.5 degrees. That was when tan of 2x is equal to 1. And two more solutions, 67.5 degrees and 157.5 degrees. That was when tan of 2x was equal to negative 1. So there are four solutions to this trigonometric equation. Right, let's move on to our second example. Sine squared x plus 4 sine x plus 3 equal to 0. And we're finding all solutions between 0 and 2 pi. So we're back into radians now. Right, sine squared x is our way of writing sine x all squared. Now, let's have a look at this quadratic. X squared plus 4x plus 3 equal to 0. So we have x squared, or sine x all squared, plus 4x, or 4 sine x, plus 3 equal to 0. So this here is just a quadratic written with sine x instead of x. So if we can take the quadratic in the box and factorize it into x plus 3 times x plus 1 equal to 0, then we can take this trigonometric equation and factorize it to get sine x plus 3 times sine x plus 1 equal to 0. Now, we should be able to say this is sine x plus 3 times sine x plus 1 equal to 0. When we have something times something equal to 0, we either have sine x plus 3 is 0, or we have sine x plus 1 is 0. Now, if we take each of these equations and pop the plus 3 on the other side to make sine x equal to negative 3, or sine x equal to negative 1. Once again, we've broken this complex equation up into smaller equations, and we can now work on our graphics calculator to solve each of these one at a time. So let's start off with sine x and put that equal to negative 3. Now, I've changed my calculator into radians, and I've gone into view window and I've changed my x boundaries between 0 and 2 pi and left my y boundaries as negative 4 to positive 4. So you can see there are no intersection points for these graphs. Sine x does not equal negative 3 because it only has an amplitude of 1. So there's no solution for the first part. But when I change this to negative 1, you can see that there is one solution here, and it happens to be at 4.7123, or 1.5 pi, if you're working it out in exactly. So when I come back here and say my solution to this problem is 4.712 radians, or 3 pi over 2. There's only one solution to this trigonometric equation within these boundaries. Cool, thanks so much for watching.